Welcome to the Elevate the Edge podcast. I'm Maribel Lopez of Lopez Research, and I'm joined with my co-host Joe Peterson of Clarify 360. If this is your first time listening to the podcast, welcome. Elevate the Edge is published bi-weekly. The podcast focuses on helping companies understand what edge computing is, how the market will evolve, and what you need to know to build successful edge computing strategies. Show notes and subscription links can be found at elevatetheedge.com/episodes. We hope you'll enjoy the show. Hello and welcome back to the podcast. I'm Maribel Lopez, and I'm joined here today by my co-host Joe Peterson, and this is Elevate the Edge. As always, we're trying to bring you new and interesting individuals to speak with. And today we're here with Roshni Bhagalia. She's the Vice President of Product Management for Editon AI and Patflorm at GE Healthcare. Editon is GE Healthcare's intelligence platform designed to help the healthcare industry improve efficiency, improve patient outcomes, and increase access to care. One of the things that's interesting about it is it tries to integrate with the other applications and assimilate data from disparate sources and apply analytics and advanced algorithms to that to help provide insights. So some of the things we love about the edge are the ability to take lots of data from lots of different places and create new and interesting insights. So this sounds like a conversation that I'm very excited to have. Roshni is a experienced technologist and product manager. And Roshni and her team create infrastructure and services that power the next generation of GE Healthcare software applications. So with that, I'd like to welcome you to the program, Roshni. How are you today?
Thank you, Maribel. Thank you so much for having me. I'm doing very well. I'm very excited to be on Elevate the Edge, and I'm looking forward to our discussion today.
Well, and today we're going to talk about Edge AI and distributed application management. And in the past, Joe and I have had many conversations actually, where we've discussed the many definitions of the edge. We've looked at several verticals, agriculture, retail, airline, transportation. As a matter of fact, today we were just talking to someone in the seaweed industry. So the edge is everywhere in all kinds of interesting spaces. We've done water utility management, smart cities, but healthcare is clearly a place where we see tremendous opportunity for the edge. But perhaps we can start with the basics. From your perspective, what is Edge AI in healthcare and how does it work?
So the use of advanced technology, especially in AI, especially AI in healthcare, has the ability to deeply and directly improve patient care and outcomes. All of this is provided it can be harnessed in a clinically viable manner. So for AI, this often means that we need close to real-time performance with high clinical accuracy and reliability. And this is what can really be achieved by running AI at the edge. So, it's in the terms, right? Edge AI is literally deploying AI at the edge. And in healthcare, the edge implies running AI on premises closer to the data sources. And these data sources are often medical devices or medical data aggregators. In several of, the examples that we have in healthcare, AI is either embedded in the medical device itself or sits in close proximity to it. And the big advantage of doing that is that you can act on that AI and get feedback from that AI, while both the patient and the clinician are still in the loop to act on the findings. With the recent advances of optimization, acceleration, and really compression of data models, it has now actually become feasible to do some very intricate and compute-intensive tasks at the edge and closer to the devices where they are more accessible to both clinicians and patients.
Roshni, you mentioned clinically viable data and the ability to keep the provider and the patient in the loop at the same time. Help the audience think about a couple use cases. And I know we're going to get into use cases a little bit later, but help them frame that up. Give me an example of somewhere where the data can come in thanks to the work you're doing, and the doctor's there and the patient's there, and a decision can be made.
Yes. So, a very simple and probably commonplace example is when you go to the doctor for either a preventive checkup or a scan. Either it's preventive or it's acute or it's chronic. But essentially, think of going to a medical facility to get a scan of the body done. In many scenarios, you get the scan done and then you go home, and then somebody else reads and acts on it. Now, while that works when it's not a latency intensive operation, maybe it's just something you have minor leg pain or something and you're fine waiting for it. In many situations, it's an acute situation, meaning you are probably actually having a stroke or you're probably actually having cardiac arrest. And in such situations, if you can get AI assisted feedback back to the clinician before you actually leave the premises, it can actually impact your quality of care. So either there's a follow-up scan that can help improve the diagnosis, or there is an urgent medical intervention that's needed, which is informed by AI acting on that imaging data in a timely fashion before the patient leaves and sort of, is lost to the system for a while. So those are sort of, very simplistic and very general widespread use cases where AI could really help.
Oh, that's a great example, because that's literally life-saving, or it could be, right?
Absolutely.
Yep.
Yeah, I think this really actually tees up some of the interesting differences in how we think about edge strategies as well, because some edge strategies have to take the data and analyze it in real time, and other edge strategies, we can collect the data, do batch analytics at a different time. It's just a different level of intensity around insight, and not all use cases are created equal in that. So one of the things I wanted to ask you about is, there are many ways to think about deploying AI models at the edge, but what are a few of the recent innovations that might be making this easier at the edge?
So there are a number of innovations that have made edge AI more accessible. And actually the last, I'm going to say 5 years have been particularly impactful. But I'm just going to call out a few here. So the first one, and probably the most obvious one, is the advent of AI model optimization, acceleration, and compression techniques. So things that, needed a lot of compute, either to run or even just to store the models, have now, some of those restrictions have gone away. And many of these techniques allow us to really compress the model, accelerate, and run it with virtually no negative impact on performance. So that's, I think, the first really obvious one. But in parallel with that, we've also seen a really strong ramp up in the availability of cheap, faster, and in many cases, specialized compute with very low power consumption. And what this does is you can now think of, moving that large compute power, which used to be relegated to maybe the data centers or the cloud providers, to really deployment at scale, especially because it can get to that lower power consumption while still giving that specialized compute. The other two things that have really helped in sort of driving this field forward, making it more accessible locally, is the growth of open source tools. And it might seem tangential to AI, but really the ability to manage and scale with cloud native technologies like Kubernetes at the edge means that you can now deploy these workloads in a very seamless fashion, in a sort of distributed framework locally for both connected and disconnected scenarios. And then the last bit, I really want to emphasize is, again, open source tools, but this time specific to cross compute optimization. And so what I mean by that is there's been a growth in tools and APIs that allow us to build code that is portable across multiple compute chipsets, with almost minimal to zero rework. And so what this means is you can develop something using that sort of open source tool or API for one compute framework, but now you can very quickly and easily run it across disparate compute across many local sites. And that can be really powerful in sort of a edge-based setting where you're no longer relying on a centralized cloud or a centralized set of resources to run your workloads.
I love what you said, cross-compute optimization. You heard it here, folks. Roshni, she came up with a term that other folks are going to use. I know that. And with that in mind, and how I'm thinking about it, and I'd love to get your insight here, is it fair to say that edge computing is sort of a middleware for like a distributed application driven process? Could we think of it that way?
Absolutely. So, I think you alluded to this earlier, Joe. Like there are a number of scenarios where data flow between cloud and on-premise makes sense. And there are some straightforward examples where sort of you're doing offline compute or delayed processing. So you have algorithms that assist, the post-scan radiologist, if you go back to our first example, where it's totally fine to get the scan done. You come back the next day or 3 days later, and it's okay to get that delayed diagnosis. There are other situations where you can do longitudinal population-based studies on archival or archived data. But when there is the need for real-time performance and real-time compute, where, in our example, it is an acute incident, and actually the biggest bang for the buck, the biggest benefit is getting that feedback at the right point of time in the care continuum when both patient and provider can act on it. Then you really need to make sure that you're not limited to network connectivity. You're not limited to throughput. You're not limited to bandwidth. And the only way that's possible is by using edge compute as middleware to create those clinically meaningful solutions and to make them very effective. I'll go back again to the plug I made about Kubernetes. Really, having the ability to leverage those cloud native technologies and open source tools means that this middleware layer can now scale. And not only can it scale if it's built right, you can even manage it remotely, even in cases where there are intermittent connectivity. And you can portably deploy it, again, with sort of that cross-compute layer on top of it across various different workloads, right, with zero rework. And that has this multiplier effect in the middleware, which really creates this continuum closer to where the patient and the provider are.
I think there's so much in there in terms of the ability to not think of locking yourself in a technical island. And I think that was one of the issues that we had with the early editions of AI, people really being invested in a specific set of frameworks. The early days of cloud, you were investing in a specific set of framework, and there was no concepts of real concepts of portability. And I also love some of the things that are happening in open source in terms of helping tools to help people understand and unpack some very sophisticated models from an explainability standpoint, which I could see might be very interesting in the healthcare field, where if a model comes up with a recommendation, you'd want to be able to explain why it had that recommendation and what some of the data sources or other things were that led to that. So I think there's a lot of power in terms of both the open source tools, but also in terms of thinking about using multiple types of artificial intelligence chipsets and stacks at the edge, the right tool for the right job, and creating those right time experiences, as you mentioned, the right information, right person, right time. I think that's the wave of the future of what we're trying to get at with edge computing. So we've talked quite a bit about some of the innovations and the opportunity, but I thought maybe you could give us a few more examples of edge AI use cases that you're looking at.
Yes, absolutely. The healthcare industry in particular has seen a very strong growth in the use of AI and machine learning in improving care. For example, the FDA recently published an updated list with about 187 new AI and ML-enabled medical devices I am going to make a quick plug for GE here because we were very pleased that GE sort of led that list with 42 cleared devices. And it just goes to show we have a very strong emphasis on leveraging AI to really improve care across all our product lines. We really sort of believe that it can have a very strong impact on healthcare. But a couple of really concrete and sort of specific examples where AI has improved things is first in sort of the acute care situation, which is very prescient. So during the pandemic, there needed to be a very rapid scale up in skilled personnel dealing with pandemic-related chronic and acute conditions. And GE and other medtech companies were able to very quickly develop and deploy AI-assisted clinical care, which eventually saved patients' lives and really allowed people to improve bedside care at scale. A particular example is something that we call the critical care suite that's deployed on some of GE's X-ray devices. And it essentially helps sort of placement and treatment plans for people who have pulmonary issues, and many of them linked directly to the pandemic. And this was particularly impactful in sort of underserved areas, in areas where we couldn't have the right set of resources or skills available simply because just the number of people that we had to deal with. And so this AI assistance was really impactful. I do want to mention and emphasize something that Maribel said early on. Explainability of AI is extremely important to healthcare, right? And so transparent and explainable AI is really valuable. But equally valuable is, clinicians want AI to be an invisible friend. And what I mean by that is they don't really want to do anything differently. They need that AI assistance at the right time, and they want it to just show up as friendly advice for them to either take or to ignore. And with the critical care suite, GE and other vendors who came up with similar solutions with the pandemic, I think we were able to really do that in the case of pulmonary care and really move the needle there. So that's one example. Another example in the not so acute care situation is, for decades now, healthcare has struggled with inverse problems, especially in medical imaging, where historically you have huge compute-intensive tasks that historically used to require supercomputers, very high latencies. You sort of had to send it off, and it took minutes and hours to process. And it looked really good in a lab, but it made it clinically non-viable. And one of the big benefits of, if we could have gotten that to be locally deployed, is that you can now start reducing dose in things like CT scans without affecting image quality, right? So really think about that. So you could now, reduce the radiation that you are impacting people to, especially, maybe compromised people or younger people, without impacting the diagnostic quality of the scan. So with the advent of AI and, some of the advances we talked about earlier, we're now able to run deep learning-based reconstruction algorithms either in the device or very close to the device. And it now makes that clinically viable. So you can actually, lower the dose, lower the noise in the scans, and really get to that high image quality, which really has an impact on diagnostic value. And then the last bit I'll add is, because I think it's quite unique to healthcare, healthcare, unlike almost any other industry, has a very sort of disparate IT infrastructure. So you go all the way from community hospitals with very limited access to the internet or to IT, to sort of big IDNs with global access and cloud-like access. And being able to give the same quality of care in both those instances is only available when you have local edge compute, because you can now take something that you could deploy in the cloud for a premier site and make it available to somebody locally, because you can use all the 3 or 4 advances, especially blended together that we talked about earlier, and really get it closer to the point of care. So I know I may have rambled on a little bit there, but there's some really strong use cases for edge AI in healthcare.
No, and I think the part that she brought up about the infrastructure as well is so important and so powerful. The changes and the availability that we have today that we couldn't have done, say, 5 years ago. When I think of AI in general, for most organizations, whether they're in healthcare or not, 5 years ago, it was much more challenging to do anything than it is today because of the availability of the tools just wasn't there. And now I think we're all, the technology landscape's making a concerted effort to make things more accessible for a broader range of skill sets, to make things more affordable, and to make it available in more places so it can be on-prem or in the cloud. Your hybrid deployment choices are really quite good these days. But I love that fact that you brought out the real true challenges that we see in healthcare, which is around not every healthcare organization has had the same access to technology in the past. And how do we level that playing field so that we can get equal care no matter where an individual lives? Over to you, Jeff.
Well, I get the fun thing to do, Roshni, of asking you a fun fact. So it doesn't have to be healthcare or tech related, but can you share a fun fact?
I think so. I'm a geek, so it might be slightly tech related.
Love it.
A fun fact is the world's first reported computer software bug was actually a bug. So on 9 September 1947, a team of computer scientists at Harvard University reported that one of the reasons their computer system was malfunctioning was because they had found a moth trapped inside their computer.
Oh, moths destroying things since the dawn of time, including computing.
That's great. That is great. Well, you have been a pleasure to have with us today, Roshni. We loved your insights. We love what you guys are doing to help make healthcare more accessible for folks. And thank you so much for taking your time to visit.
Likewise, and thank you very much for having me. I listened to some of your previous podcasts, and it's a delightful series. So I'm looking forward to tuning in more often. And happy Thanksgiving to you.
Happy Thanksgiving to you as well.
And happy Thanksgiving to all. Although people hear this after Thanksgiving, we hope that you have a joyous holiday season whenever the holidays happen for you. Take care, everybody.
Take care. Bye.
Bye.
Thanks for listening. If you enjoyed this show, please subscribe so you can easily find us again. Follow us on Twitter at Maribel Lopez and at Digital Cloud Gal, and on LinkedIn. Links to our social profiles, show notes, and ways to listen to the podcast can be found at elevatetheedge.com.